I'd like to introduce Joee Patterson. She is indeed a friend of the Maine Coastal Islands National Wildlife Refuge. I've known her since she's been on many of her expeditions to the Antarctica and always hearing wonderful stories. So it's great to see this in one big meeting because I've never really sat down to see a whole slideshow from her. So let me get her on here so you can say hi and enjoy the presentation.
Hi, everybody. I see some special faces, and I'm really excited to see all of the people that are coming in tonight for this talk, so I hope I don't disappoint. I'm going to go ahead and get my screen share going, and then we can talk about Antarctica. I'm very excited to be sharing this with you tonight. All right. Well, I wanted to say thank you all for joining, and also I wanted to thank Carney and the Friends of Maine Coastal Islands National Wildlife Refuge for hosting this event. And I love talking about Antarctica. And I learned a new word this week, which is ensorcelled, which means to be held in the spell of a mythical power, which I was like, that is the word I've been looking for to describe my experience in Antarctica and how it makes me feel to see that place and to be in this place. I could easily do an hour on each of the 9 cruises that I have done down there, but for now I've broken it up into 3 basic parts just to kind of keep it within the bounds of everybody's attention span. I'm going to start with a little bit of history, and then I'll give you a sampling of some of the different types of science I've been involved with. And finally, I'm going to talk about traveling to a previously uncharted part of the Antarctic coast to study Thwaites Glacier in the winter of 2019. The photos that I'm showing in this, just so you guys know, are a mix of some of my own personal photos and some that were shared by shipmates, and you'll see there's some technical stuff that I got off the web from the US Antarctic Program. So I just want to mention, this is me on a very cold day in a very remote place. And I wanted to just mention right off that I am not a scientist and I don't have a formal background in science. As a marine technician, I rely on the skills that I cultivated as a mariner and sailing schooners on the coast of Maine, and also working in boatyards around Maine. But in addition to those manual skills and those technical skills, I also need to have enough of a foundation of scientific literacy to fully facilitate the field work. I need to understand what the objective is and what's going on in order to be of use to the scientist. So for the purposes of today's discussion, you should know that I'm doing my best to be accurate, but I'm not speaking on behalf of the scientists or National Science Foundation or the US Antarctic Program. However, getting to learn about science is one of the big highlights of this job for me. So I know that we're all here to learn about Antarctica, but I wanted to take a moment to tell you of some interesting connections between Maine and Antarctica. The Gulf of Maine is one of the most rapidly warming bodies of water on Earth, and the complex archipelago of islands that traces our coast is a host to a diverse assortment of species whose life cycles and behaviors can be important indicators of the effects of those changes. I spent some time working with the Friends, and during that time, I learned to my great astonishment that excluding Alaska, 96% of the Arctic terns in the United States are produced on just a few small islands along the coast of Maine. And even more mind-boggling to me is the fact that some of those birds born in Maine will make an annual migration to the coast of Antarctica to feast on the abundant krill swarms that fill Antarctic waters during the months of our winter. This map shows data collected from geolocators that were attached to terns for a study that was conducted in 2010 by our very own wildlife refuge biologists. The green lines represent the fall migration going south. The red represents flight patterns during the austral summer, and the yellow represents the routes of the northern migration, or the migration back north. This study was the first time that the Arctic tern's 44,000-mile migration, which is the longest known migration of any species, was definitively observed. And I can tell you, I was thinking a lot of these tiny little birds that fly all this distance when I was making my 32-hour journey from Maine to the southern tip of Chile. So I can't talk about Antarctica without creating some historical context, because the moment that you arrive in southern Chile, you realize that you are becoming a timeline of human interaction with Antarctica. When I arrived for the first time, the town, Punta Arenas, which is the town that we meet the ship in, was celebrating the 100th anniversary of the rescue of the Shackleton expedition. There was a full-scale replica of the James Caird, which is the boat that Ernest Shackleton sailed to South Georgia Island. That replica boat was sitting in the lobby of the hotel I stayed in before meeting the ship. There were all sorts of celebrations around the town that were embracing this history. And as soon as you get to Punta Arenas, you're sort of overwhelmed with the sense that you're becoming part of this long legacy of exploration and endurance. I like to include this view of Antarctica because we usually see Antarctica represented as a strip at the bottom of a map, which doesn't really give you a sense of the size of the continent. So this is just to give you a little bit of orientation. As a mariner navigating in the North, who's accustomed to navigating in the North Atlantic, it really messes with your head when you get down here and literally every direction is north. But if you look up at the top of the screen, you can see this is the point of southern Chile, which is I think it is the closest point of land to the northernmost part of Antarctica, which is known as the Palmer Peninsula. That's this little spiky bit right here. And I will be talking quite a bit about the Palmer Peninsula. And then down over on this side, you've got New Zealand and Australia, and then way over here is South Africa. And so Antarctica is just centered at the bottom of the planet. So this is the Palmer Peninsula, or I'm sorry, excuse me, this is southern Chile. And like I said, this is the closest point of land to Antarctica. And the Palmer Peninsula hosts a tremendous amount of biological activity and within the Antarctic ecosystem. And for that reason, it's of great scientific interest. So it's a target of the majority of the ship-based science that takes place in Antarctica. Southern Chile is the closest point of land. And so Punta Arenas, which I've got in the yellow circle here, has been a jumping off point for many Antarctic explorers. Its location in the middle of the Straits of Magellan, which is this body of water that bifurcates the bottom of Chile, makes it an ideal location from a navigational standpoint because it's relatively accessible to Antarctica and yet in this area that's protected from the wiles of the Southern Ocean. This is Nathaniel B. Palmer, and he is credited as the first exploration of what is now known as the Palmer Peninsula, so it was named after him. In 1820, he sailed to the coast of Antarctica in this little sloop here called Hero, which is about 47 feet long. And he was just pushing further and further south in search of seals, which he was hunting for oil. Also in 1820, Bellinghausen and Bransfield reached the continent, but it wasn't until 1895, 74 years later, that the first undisputed landfall was made by a team from the Norwegian ship Antarctic, which went ashore to collect geologic samples at Cape Adair. And Palmer's arrival on the peninsula marked the beginning of what we call the heroic age of Antarctic exploration. And at that point, once landfall had been made, really every major power in the Northern Hemisphere wanted to stake a claim, so there was a bit of a land grab. And that's around the time that you start seeing explorers rise to prominence like Roald Amundsen, Ernest Shackleton, and Robert Falcon Scott. There are tons of books and films about this era, and it's really interesting stuff, and I highly encourage you guys to delve in. There's just some unbelievable tales of human endurance. So to give you an appreciation of the navigational challenges that these early explorers faced, I want to just give you a sense of scale. So in the center of the screen here, you can see the Nathaniel B. Palmer. This is a research vessel that I traveled down there on, and she's over 300 feet in length and about 90 feet high at the highest point of her superstructure. So knowing the size of this vessel, you can see that she's absolutely dwarfed by these giant tabular icebergs. Inside of this little yellow circle is me in a 19-foot zodiac. The ripples that you can see on the edge of the picture here were caused by an unseen calving event near one of these tabular icebergs. Nathaniel Palmer's Hero was just a little over twice the length of my Zodiac. And when you consider that these shores were first charted by wooden sailboats without the advantage of modern navigation equipment or even very good optical tools, it's pretty breathtaking. And this is just an example of some of the very close quarters navigation that we do down there. There's a lot of tight turns and you're always in deep water with big currents. So for the next 140 years, Antarctica was explored and charted, and some science was conducted, but interests were largely commercial, political, and in some cases military. And all the American research stations were originally built as Navy installations in the 1950s. In 1961, the Antarctic Treaty was enacted, and that established Antarctica as a scientific preserve. It banned all military activity on the continent. The Antarctic Treaty was the first arms control agreement to occur during the Cold War. And 8 years later, in 1969, the US Congress changed a law that banned women from traveling to Antarctica. So glad they got on board with that. And now there are about 70 science stations in operation around the continent. And in the summer, there are 4,000 people roughly working in Antarctica, and in the winter that number falls down to about 1,000. So in the United States, most scientists who want to study do so by getting a grant from the National Science Foundation, which funds the US Antarctic Program. The three primary stations for USAP, which is what we call the US Antarctic Program. The three primary stations are Palmer Station, which is up here on the peninsula that I was just talking about, and McMurdo Station down here, and then we also have the South Pole, which is an international or collaboratively run station. Both terrestrial and marine science is conducted, but tonight I'm pretty much only going to be talking about the marine side of things because that's where I have the most experience. But there's tons and tons of interesting science happening in Antarctica. And actually, as a sidebar, a very good friend of mine from the olden days, her husband used scientific methods that he developed in Antarctica to establish the existence of glaciers on Mars, which now his field of study is studying the movement of glaciers on Mars and getting a better understanding of the existence of water on Mars and what that might mean scientifically. And I just think it's really neat to think about the breadth of science that's being conducted and how important it is that we have this extremely alien place that we get to explore and kind of poke around and learn more about. Anyhow, so this is McMurdo Station, and in the summertime they've got about 1,000 residents. You can see this is basically like a bustling metropolis. There's the New Zealand base is actually quite nearby, and McMurdo and the New Zealand base share an airfield, so they actually fly planes in and out of McMurdo. And the one time that I got to go down there, I got on a C-130 in New Zealand and flew 8 hours over the Antarctic ice sheet to get to McMurdo, which is where I met the ship. And I think I'm not sure if you guys can see this very well, but the ship is kind of over here on the right-hand side of the screen. And this is Palmer Station, which you can see is a much less complicated operation. Lawrence M. Gould, which is one of the two boats that I will talk about tonight, is primarily dedicated to servicing this station. It does provisional runs back and forth to Chile once a month during the summer. Somebody's got their microphone. Yeah, so Palmer Station has about 40 residents when it's at its peak operations. And I think South Pole Station, which I have not been to, has about 200 people working there. So one thing that's worth noting is that each year over 40,000 tourists visit Antarctica. And when I learned that number, I was just sort of blown away by the fact that there's that much human traffic there. They're very restricted in their access, but they still have a notable impact, especially because the most accessible part of Antarctica is the Palmer Peninsula, which is also the most biologically productive. So the stakes of human impact are incredibly high in this area. And so this photograph on the left, or my left, is just some tourists who are out kind of jaunting around, checking out a penguin colony. And then over here you can see on my right hand side, this is a piece of scientific equipment, and in the background you can see the cruise ship. And it was kind of interesting to me to learn that the cruise ships will sort of chatter back and forth over the radio to make sure that they're not in the same bay at the same time, because they want to keep the appearance of a pristine wasteland. So that's always fascinating. So after the Palmer Peninsula, or after Palmer Station became a civilian operation and was no longer run by the Navy, USAP needed a boat to provision the station. And the Gammon Shipyard, just down the road in South Bristol, Maine, was commissioned to build Hero, which is the first boat specifically commissioned to support science at Palmer Station. And Hero was launched in 1968, and it was in operation until 1984. And after that, there was kind of a liminal period where USAP chartered various vessels to service the station, and until they later built the two ships that I have worked on. And so Hero was about 125 feet. She had a little sail rig, mostly for stability, and she was wood, which was just so shocking to me to think that as late as the mid-1980s, there was a wooden vessel making its way through these ice fields to provision the science station. And P.S. shout out to Maine boat builders. That's pretty darn cool. So in the 1990s, the the National Science Foundation commissioned these two vessels to be built. Each of these vessels are purpose-made research platforms that are capable of carrying multiple 20-foot shipping containers. They were built and they are owned and operated by Edison Schwess Offshore, which is ironically an oil company that's based in the Gulf of Mexico. And they are chartered by the National Science Foundation. So Edison Schwess provides the captain and crew, and the National Science Foundation provides the technicians and the logistical point person. And then the scientists are kind of their own separate deals. So it's an interesting thing working on a vessel where you essentially have three separate entities that are trying to work together. So, the Nathaniel B. Palmer, which is the larger of the two vessels, is actually an it's ice class rated A2 icebreaker, which I'm not super familiar with the parlance of icebreakers, but it's kind of a light duty icebreaker, but she is capable of breaking ice. And I've seen that boat go through 4-foot thick chunks of ice like it was nothing. The Lawrence M. Gould, which is on the other side here, is a slightly smaller vessel. It's better for the close quarters navigation that is required to get in and out of Palmer Station. And she's ice strengthened, but she's not actually rated as an icebreaker. And you can see the two. This is a really unusual thing to see both of the boats side by side, but here they are. And the Palmer is on the right and the Gould is on the left. It takes a little over 4 days to get from Punta Arenas, which is up here, down to Palmer Station. And we have to cross the Drake Passage, which is this strip of dark blue through the middle here, which is a famously treacherous body of water. This is a wind map for those of you who have never seen one before. And the closer to red or purple the color is, the more intense the winds. And the winds, Punta Arenas kind of sticks down into the roaring 40s, and essentially all of the wind that is whipping around the entire world unobstructed reaches the Drake Passage and then tries to funnel itself through. And a lot of these storms are formed in the Pacific, where like warm air is moving over New Zealand, and then we get a lot of stormy weather, and you can see some pretty impressive seas down in the Drake Passage. We plan our trips very carefully and do our best to avoid these storms, but it just isn't always possible. And that's when we're grateful that we have very capable ships. At this point, I've only worked as a marine technician in the US Antarctic Program, and they organize, USAP organizes science support a little bit differently than some other institutions. In my experience, the MTs are primarily focused on the back deck operations and small boat operations, which is running the Zodiac. We do a lot of physical labor, mostly deploying and recovering sampling equipment and also overseeing remote operations, as well as any sort of handiwork the scientists might need, which could be building shipping crates for shipping the samples back at the end of a cruise. It is repairing the sampling devices when they break, which often requires us to improvise, do a little bit of MacGyvering, and also the repairs and maintenance for the Zodiacs and their engines. And so that's sort of an overview of what the marine technicians do in the Antarctic program. Their roles are defined differently in other research programs. So don't be surprised if you meet another marine technician that has a different story to tell. So the next few slides are just a sample of some of the work that I have participated in. And you'll see this designation, LMG 1605. So what that means is Lawrence M. Gould, and it was 2016 and the 5th cruise of that year. Excuse me. So this trip was part of an ongoing study that focuses on a few species of fish found only in Antarctica. And we would dredge the bottom at depths close to 900 meters with an otter trawl net, which, if any of you are in the fishing industry, you're familiar with this piece of equipment. It's basically a big cone that scoops up fish that you drag along the bottom. And so we would pull up these massive jumbles of sea life, which we would then carefully sort through to find several target species. And this was a really delicate operation, as the fish had to be alive and healthy so that they could be brought back to Palmer Station and used in a breeding program that produces fish embryos, which are then frozen and sent to labs around the world for a variety of experiments. Excuse me. So down in the bottom with the pale blue background, you can see the Antarctic ice fish. So the Antarctic ice fish was the target species on this cruise that we were doing. They're really unusual. Their blood has no hemoglobin, so it's clear. And additionally, it has anti-freeze properties to help them cope with the below freezing temperatures that they encounter at these extreme depths in the Antarctic. They are also extremely good at extracting calcium from their environment to build bone structure, where it's very energetically expensive to do that in the environment that they live in. And for this reason, they're being used in a study that is looking at how their genetics might lead us to a cure for osteoporosis. The other fish in these pictures here are just some of the bycatch. They weren't target species, but they were scientifically interesting, so they were recorded and looked at by the lead scientist. So this one down here was called a dragonfish. I don't really know anything about the dragonfish, but they're pretty cool looking. And this guy up here that's sort of pink and mottled, that's the barbled plunder fish. And this strange sort of ghosty looking little guy with dark eyes is a snailfish, which was a relatively newly identified species. There have only been a few specimens of this fish ever recorded, and so the ichthyologist that we had on board was really excited when we pulled this extremely nondescript globby little fish up. So the next cruise that we're going to talk about was one of my favorite cruises. The purpose of this cruise was to collect live krill samples and algae for incubation experiments, and to collect fecal samples from wild krill. As the sea ice around Antarctica continues to recede, the ice edge itself gets closer to the hole in the ozone, exposing the vital and extremely delicate ecosystem that thrives around the edge of the ice. And as the ice is receding, it's being exposed to higher levels of UV radiation. And we know that UV can cause certain lipids, which are a type of fat in the food chain, to become toxic. And so the purpose of this study was to look at the evidence, look for evidence of bioaccumulation of these toxic molecules in krill, which could indicate that there's a threat to the rest of the food chain. To catch the krill needed for these experiments, we needed to primarily use, or we primarily used a midwater trawl net, which allowed us to catch huge numbers. But the scientists wanted to try a more targeted approach, which is how we got this really cool video. And hopefully this video is coming across for all of you guys. Yeah, we had collected krill with these midwater trawls, and this is the environment that the krill are really thriving in. And for the sake of this experiment, it's a really interesting place because there's sunlight penetration, and this is where algae tends to grow most abundantly. And so the krill that you see here are all down there feeding on the algae that's at the edge of the that ice flow. You can see our happy scientists. They were very excited about their zip tied fishnets. So algae grows within the layers of the sea ice as well as along the edge, and there's light penetration through the sea ice, and so you'll actually see when you look at layers of sea ice that there's like strips of green and brown that go through it, and that's live active algae. And sometimes when there are pockets in the ice, you'll actually see krill have made their way into the pockets of that ice. And so to get algae for the incubation experiment, we drilled into the ice with a core sampling device, and some of the samples that we drilled out were over 4 feet thick. And to get to the sea ice, we would lay the ship up against the ice field and use a crane to swing our team over. So you can see us standing on the little personnel basket, and that's actually dangling from a crane on the ship. And this picture down in the bottom right-hand corner is probably my favorite picture ever taken of me at work. It's just absolute joy, cold and snowy and dark, but it's really fun to be out there even in conditions like that. One way of measuring bioaccumulation of toxins is by analyzing fecal matter. And to acquire fecal matter or fecal samples from wild krill, we would use a sediment trap, which is essentially a giant funnel with a bucket at the bottom. And we would deploy that from the ship and then use the Zodiac to secure it to an ice floe. And then we would return and collect it the next day. So this big sort of windsock looking thing, it would hang vertically in the water column, just like you see it oriented here, and it would be anchored to an ice floe. So it actually just dangle below the ice floe in that area where all the krill are feeding. And then after 24 hours, all of their little krill poops would kind of filter down into that little bucket at the bottom, and we could go back and retrieve that. And that's what the scientist was looking at in this study. I love the trawl net. I get very excited about plankton. I think the first time that I saw the results of a plankton trawl, I was just completely enthralled by it because there's so much diversity of life in these swarms of krill. And so this is a video that I took of krill swimming around in a bucket on the ship. And if you look closely, you can see there's this sort of orange and yellow thing that's coming into view in the middle of the screen. And if you look really closely, you can see it's got translucent wings. I'm going to play that one again for you. Oops, not that one. So this little orange guy that's swimming around is known as Cleone limacina, and this is a mollusk that doesn't have a hard shell. And I don't know why, but at some point in its evolutionary history, it developed wings. So the Cleone limacina are just down in Antarctica, kind of swimming around with their little wings, which I think is great. And we are always of great interest to the locals. How are these videos coming across, Carney? Are they looking good?
Yeah, they're working fine for me. Yep.
Great, wonderful. Glad to see that. So I'm not the only one who gets excited about the work. The locals would often come kind of check us out. And I was on the ship, and my job was to keep an eye on this ice floe because this massive ice field is not actually attached to anything. And when you get at big ice fields like this, you don't always know exactly how stable they are. So there's a lot of precautions that we take. We use probes, we take core samples before we get out of the man basket to make sure that there's thick enough ice underneath us. But these ice fields can be destabilized, especially once we lay the ship up against them and you have the force and the motion of the ship rubbing up against it. And cracks can start to form. So whenever we had a team on the ice like this, we would always have 2 or 3 people who were designated to just keep an eye on things and alert the bridge and alert the shore team if they saw any destabilization of the ice field there. All right, so now I'm going to tell you guys about the International Thwaites Glacier collaboration. This cruise was part of a multi-year collaboration between the US Antarctic Program and the British Antarctic Survey. And they were there to study what some people have referred to as the Doomsday Glacier. And for that reason, it's receiving a significant amount of media attention. On this expedition, we were accompanied by a reporter from Rolling Stone, as well as a journalist from Public Radio International, and Elizabeth Rush, who is a Pulitzer Prize nominated author who is working on a book about this trip. So some of you might recognize Elizabeth Rush's name because she is the author of a book called Rising, which discusses the effects of sea level rise on coastal communities. Well, why would you call it the Doomsday Glacier? To begin with, Thwaites Glacier is about the size of Florida, and the volume of water that is trapped in Thwaites just by itself could account for up to 2 feet of sea level rise within probably the next 100 years, if it continues degrading at the rate that it currently is. So we've all seen the really dramatic video footage of large calving events like the Larsen B ice shelf, and we sometimes will hear reports of, iceberg the size of Cyprus just broke off of Antarctica, right? And that sounds scary, and it can indicate a destabilization, but those calving events are not actually what we are concerned about when we're concerned about sea level rise. Thwaites is, and this, I'm sorry, let me back up a little bit. The reason that calving events like the Larsen B ice shelf do not contribute to sea level rise is because, as you can see in this diagram of Thwaites Glacier, that is the part of the glacier that is already floating in the ocean. So if you see this point right here is really the important point, and this little, I don't know if my mouse is working.
There you go.
There we go. This little spot right here is extremely critical when we're talking about the degradation of major glaciers in Antarctica and on the northern ice cap. When you see something like the Larsen B ice shelf, that's this chunk of ice breaking off and floating away. And it's kind of like if you had ice cubes in a cup and the ice cubes melt, the level of water in the cup doesn't really change. So even really big, scary ones don't necessarily contribute to sea level rise. However, those that tongue of ice that's hanging out over this gap here is part of this larger glacier. And so if this continues to recede, what will eventually happen is this little, this little spot here will start to open up. And you can see in the case of Thwaites Glacier, there's actually a downward slope. So once all of this breaks off and floats away, this seawater, which has a higher temperature, or a temperature that's warm enough to melt ice, will start to flow into this spot underneath the glacier. So in addition to the environmental factors that are causing melting and destabilization on top of the glacier, you will also be getting melting and destabilization below the glacier, and that combination can can dramatically increase the destruction of the glacier, the melting of this glacier. So when we're talking about sea level rise, what we're talking about is the part of the glacier that is currently sitting on land and not contributing to the volume of the ocean. When that starts melting, that is what contributes to sea level rise. So that's one reason that Thwaites is important, is because we know that it has this downward slope. And so we want to better understand how that is all working. Sorry, I thought I heard someone come in the front door. So it's got this downward slope, and we want to better understand that. The second reason that we are interested in Thwaites Glacier is that it acts as a dam that keeps the rest of the sea from infiltrating the West Antarctic ice sheet. And if Thwaites is compromised, it could lead to exponential glacial melt, and that could result in something on the order of 10 to 13 feet of sea level rise over just a few centuries. The International Thwaites Glacier Collaboration, which, as I said, is primarily led by the British Antarctic Survey and US Antarctic Program, has a bunch of other organizations, a bunch of different scientists working under that umbrella. There's a myriad of scientific surveys that are happening kind of all at once. Some are being conducted on the top of the glacier. There are some scientists who are drilling through the thickness of the glacier to get access to this water that's down here and take measurements and collect data. There's aerial surveys that observe the condition of the surface. And we were primarily conducting work at the front of the glacier. So that's represented by the little red ship here. And our objective on this trip was primarily reconnaissance and information gathering for planned future expeditions. Some of the scientists on this cruise were looking closely at the currents that are around Antarctica. So most of you are probably familiar with the Gulf Stream, and that's essentially what these are. Like they behave like the Gulf Stream, where they are discrete bodies of water within the larger ocean, sort of like a subsurface river that is relatively self-contained. So each one of these currents has a distinct profile of temperature, salinity, and the depth that it likes to hang out at. And so by determining the location of these currents and tracking their movement over time, we can start to understand how they might be affecting the melting process of the remaining ice in Antarctica. So each one of these blue lines that you see in the photo here is representing a current that has a distinct temperature and salinity profile. And some of them are warmer than others. So if these currents are moving closer to the ice sheet, that could give us some indication that maybe we should expect the glaciers to be melting even faster. So all of those currents, like the Gulf Stream and the Antarctic Circumpolar Current, are so distinct that they actually support discrete ecosystems comprised mainly of microscopic plants called diatoms. And diatoms have skeletal structures that are made of silica, which will filter down to the seafloor when they die, and each species is as unique as a snowflake. So analysis of mud from the seafloor reveals layers of diatom skeletons, and from that we can discern how the positions of the currents have fluctuated over time. So as those underwater rivers are moving back and forth to and from the shore over the course of hundreds or thousands of years, they're essentially leaving a breadcrumb trail of the skeletons of these microscopic creatures. So if we can get those, we can have a sense of what the track of that thing has been over long periods of time. And with good samples, we can create a profile that goes from the very present moment. And as you can see in this mud sample collected with our mega coring device, we got such a perfect sample of the seafloor that there were actually living creatures that are on the top. So we can get right now what's going on this minute, and then we can use these larger, heavier coring devices like this one here to take longer, deeper samples of mud. So this device that you see on the left-hand side of the screen is called a casting core, and it's a very heavily weighted square-shaped tube that we essentially just plunge into the mud at the bottom of the sea, and it, the tube fills up with mud, and then we extract it and bring it up, and the scientists are then able to look at the very, very, very thin layers of mud and figure out when that current was sitting over that part of the seafloor. And these samples can go back, thousands of years, so you can get quite a lot of information. On future cruises, they're going to be using a device called the jumbo piston core, which can retrieve samples up to 80 feet long, which could represent millions of years of information. This device is called a CTD, which means conductivity, temperature, and depth, and it's deployed from the side of the ship. It collects water samples and carries an array of sensors that send real-time data back to the ship. So the CTD is the workhorse of physical oceanography, which is the study of those currents, but it requires a lot of ship time and personnel. This object is about 6 feet high and weighs about 1,400 pounds when it's full of water samples. And every single time we want to put that in the water to get a set of samples, somebody has to stand by the open door in the ship and get it out there and hope that the weather holds for the duration of the sampling, which can sometimes be hours, and then get the thing safely back on board. And so it has provided tremendous amount of important data, but it's also somewhat cumbersome way to do things. So one of the scientists that was on the Thwaites cruise, a man named Lars Boehm, who has developed a new way of acquiring data by miniaturizing the CTD, or the instruments that are on the thing that I just showed you. And so he was able to miniaturize those instruments and find a non-intrusive way of affixing it to a seal's forehead. So now each time the seal dives, the CTD clicks on and starts recording data, which is all of the data that we would have collected with our big sampling device that I just showed you. So these seals will do multiple dives a day, and they will retrieve massive amounts of data. And once they come back up to the surface, that little antenna will transmit the data to a satellite, and then it can be collected from the comfort of the scientist's own home. To be able to collect the same amount of data that these seals get would cost millions of dollars and tons and tons of ship time. And for those of you who are worried about the seal and how they might feel about this dorky looking hat, when the seal molts at the end of the next winter, the device simply falls off and goes away forever. And this is a picture of Lars, and I wanted to include this because working with animals in this capacity, it can be kind of fraught. And I was really delighted to get to meet someone who does this, has been doing this for decades, and to see that in spite of the fact that Lars isn't a biologist and his goal in life isn't actually studying seals, he wants the information that the seals are able to get for him. However, he had a really deep respect for the animals, and in this photo, he's waiting for the seal to come out of its anesthesia because he doesn't want her to get spooked by all the people that are doing work around her and jump into the water before she's fully out of anesthesia. So he's just kind of sitting there quietly and waiting for the seal to be fully conscious and safely able to swim away. And he's kind of the guardian of the seal in that picture. So we had the mud samples that we were collecting, which tell us about where the diatoms have ended up, which can help us learn where the currents are. We have our CTDs and our seals that are telling us where the currents are now, today. And then we had this really cool toy, which was kind of the star of the show on the Thwaites cruise. This is a scientific submarine that was brought by a Swedish team from the University of Gothenburg. And I happen to know one of them is watching right now, so hopefully I get this right. This model of autonomous submarine is called Hugin, which is named after one of Thor's mythological pet ravens, which I think is really neat. And it can complete fully autonomous 24-hour missions. It's capable of acoustic profiling along the bottom and also water sampling. And these machines were designed for the Norwegian oil and gas industry, and they were made to inspect underwater pipelines. So they have extremely refined sonar, which can give us very clear pictures of what the bottom actually looks like. And this one in particular, which we referred to as Ron, who was a goddess in Norse mythology, I think a sea goddess, was the first to be modified for scientific use. And one of the things that we wanted to be able to do with Hugin, which you can kind of just see poking out here on the left-hand side of the screen, is to get closer to the ice shelf and get information that neither the ship nor the seals could readily acquire. Because when you get close to the front of a glacier like this, it can be a little bit sketchy. It's hard to predict when the ice is just going to start to let go. So we always keep a safe distance in the ship, and you can't necessarily rely on the seals to get to exactly the place that you're trying to get your information from. So on this cruise, we wanted to test the capability of Hugin and see if we could get in here under the ice shelf, which is really where the most critical information is. Because like I said, we're trying to figure out what is the temperature of the water in here and how much is it contributing to the recession of this ice glacier. And this is a side-by-side example of the ship's profiler, acoustic profiler, and Hugin's. And this blurrier one is the one that we have on the ship, which was the one that we have on the ship is actually a very good piece of equipment, and scientists who know what they're looking at can glean a lot of information, even from looking at what just looks like a big fuzzy blob. They can learn about the depth of the sediment, which can help us decide where we want to do our coring, and we can get some ideas about features along the bottom. But on the right-hand side here, you can see the imagery that we got back from the Hugin, and this imagery is so refined that we can really start to get a clear picture of what has happened geologically on the seabed around Antarctica. And you can imagine that this is, for geologists and really everybody, like all of the scientists, this was very exciting to see such clear and refined pictures. So with all of the tools that the scientists have on this trip, we can start to form a more complete picture of what is actually happening. How fast is the glacier receding? Has it receded beyond this point that it's currently at in the past? Is this an inevitable process that is, I mean, within, you know, the scope of human understanding? Glaciers over time, sometimes they grow and sometimes they recede. And one of the things that we're trying to understand by collecting all of this information is Thwaites just going to continue receding? Is that the path that ice is on for, you know, the rest of human existence? And all of this different information that we're gathering helps us get a picture of where the ice has been in the past, and that gives us a sense of where it might be in the future. So by combining all of this, we can better understand how the warmer currents are affecting Thwaites, both past and present. But first we have to get there. And from Punta Arenas, which is way up at the top of the screen, all the way down to Thwaites Glacier, which is way down here, is an 8-day transit. And during an 8-day transit, you start to get excited about anything that disrupts the horizon. Unfortunately, the horizon can be very beautiful. But those are some images from a long transit. And you know, we had an international ping pong tournament in the hold of the ship to help us pass the time during this long transit. And as we get further south, you start to see more and more ice. And eventually the ice becomes very consolidated. And we actually had to break through a very thick band of ice to get to where it was that we were going. You can see the ship in action here. And the ice was so thick here that we would sometimes spend the better part of a day just trying to make a mile or two through the ice by backing up the ship and ramming it into the ice, and that cracks the ice and kind of slowly brings it apart. And then after 8 days of sitting and listening to the sound of ice grinding against the hull, you're there and it's all systems go and it's time to make the science happen. And our first stop on this trip was a remote cluster of islands, and we went there primarily for the seal tagging team and a group of geologists who are looking at fossils on the beaches. So the moment we get there, we assess the weather and we get the boats in the water, and the marine techs drive the scientists out to these remote islands and penguin colonies and seal colonies. And you can see in this photo, it's a pretty blustery day and it was quite cold, but you don't really get the opportunity to wait for a calm, placid, warm day when you are doing work in Antarctica. And after 8 days at sea, everybody was very excited to finally get ashore and get to work. And I just wanted to point out that this woman in the orange hat and this tall guy over here are Megan Spoth and Scott Braddock, who are both at Maine, which was cool to have some other Mainers down there with us. So here they are digging for penguin bones with plastic spoons, and finding these fossils on the beach is yet another way that they can establish the historic boundary line of the glacier. So Lars was hoping to tag elephant seals because they are the deepest diving seals. They have recorded elephant seals diving up to 3,000 meters, which is around 9,000 feet. But first, he had to get close enough to them to see if they had finished shedding their summer coat, or winter coat, I guess. Because when he glues the device to their head, it needs to stay on for as long as possible. So if they have not yet shed their fur, then he won't put the device on them, because that means that they're just going to shed soon anyway. And he'll lose the device before he gets very much information from it. So this is Lars. He, as I said, has spent a very long time around these animals and really understands their behavior and how to deal with them. And somebody asked him at one point if he had ever been bitten, and I think he said once, but it was my fault. So the wind chill was 35 degrees below zero. And when I was driving the Zodiac around on this day to get the scientists out to these islands, the seawater was just instantaneously freezing on my float coat. But the Adelie penguins and the residents of this island didn't really seem to mind. You can see that big boy moving down the beach. So in addition to the seals, you can see there's just dozens and dozens and dozens of Adelie penguins in the background. And they had their babies from that spring were just getting past the cute phase, and the parents were all sort of being pestered by these hungry little baby Adelies who still wanted to be fed, and the parents were like, no way, man, you're on your own. It was pretty funny to like watch that little drama play out while we were doing our work. And you can see down here on the right-hand side of the screen that that's one of the Waddell seals that has a little CTD on its head. So all in all, it was a pretty successful day of science, and we were getting ready to pack up to go back to the ship, and then this happened. I was heading down to the Zodiac to prepare it to load in the scientists in their gear to go back to the ship, and this rather mean-looking character had hauled himself up on the beach and placed himself right between me and the Zodiac. So fortunately, I had Lars to help me out, and he and one of the other scientists distracted the big brown one that was up on the beach. And this guy had kind of like slid in and out of the water a little bit. And so they distracted the big brown one and said, you know, you can go past him and get into the boat. And I got into the boat, and this guy who was kind of down at the edge of the water was sitting there, and he was looking at me and I was looking at him, and I was standing there by the engine, and the seal opened his mouth really, really wide and sort of put his lips around the end cone of the Zodiac. And I stood up really quickly and I was like, no, don't bite my boat. When I was growing up in Alaska, we were taught to be assertive with large mammals, and that proved to be a good tactic with these giant male elephant seals. And I would never have thought that I was intimidating enough to scare off a fully grown male elephant seal, but he didn't want to tangle with me, and he sort of sloughed off into the sea and left us alone, and we were able to get home all in one piece. So finally, after the 8-day transit and a few days in the Edward Islands, tagging seals and looking for penguin fossils, we arrived at Thwaites and became the first human beings ever to see the edge of this glacier or chart the waters. And it was a truly profound experience. Several of the scientists on board commented that the degraded look of Thwaites' edge and commented on the degraded look of Thwaites Edge. Healthy glaciers usually have bold cliff-like edges. You've probably seen lots of pictures of that, but Thwaites shows signs of breaking up and refreezing, which compromises the structure of that ice tongue and can cause a more rapid recession. So like once that ice tongue starts breaking apart and refreezing, breaking apart, refreezing, then it just becomes easier for it to break apart and start melting. And then once the ice tongue is gone, the glacier itself is exposed essentially. And so our concern again is the rapid recession of this ice edge. So these are some more photos of the edge of Thwaites Glacier. And yeah, this is really great photo demonstrating just how kind of broken apart the edge of Thwaites Glacier was. Once we arrived at Thwaites Glacier, we began deploying the Hugin. This photograph is actually from a test deployment we did before we left Chile. So the Hugin is about 20 feet long and it's self-propelled and can go up to about 4 knots. Our ship was not able to accommodate the recovery system that had been designed for these units, so we had to improvise, which was often challenging. This was our very first attempt, and it's not very graceful, but we did get better at it as we went on. And just to, as we were struggling to recover the Hugin on our first attempt, you can see the weather is not as nice as it was when we initially launched it, so recovering it was a little bit challenging. And just to kind of rub it in our faces, this little fur seal came up and was checking us out and just diving gracefully and powerfully through the water while we were trying to get control of this 4,000-pound submarine. So you can see here, this is the configuration we eventually ended up with, towing it on the hip with the Zodiac. And even that was pretty challenging for those of you who have done any kind of small boat handling. You can imagine that having a 4,000-pound, extremely dense torpedo-shaped object that wants to stay below the water attached to your relatively light and buoyant Zodiac makes maneuvering pretty difficult and challenging. Also, the wind and the waves will affect the two things differently. And so I learned a lot about boat handling in unusual circumstances on this trip. And this photograph I just like to show because it gives you an idea of what the back deck of our ship looks like when we are doing science. Underneath the big A-frame here, which has a wire that runs back to a big winch on the ship, you can see the Hugin is dangling in its harness on the little railway that we would use to launch it. And then this red railway along here that these fellows are standing on is how we would deploy the coring equipment. So Hugin was our problem child. Like I said, the recovery was challenging. Sometimes, you know, the submarine would do up to 24-hour deployments. So the technicians that were working with the submarine would run a computer program into it with plot points on a chart, and we would put Hugin in the water, and Hugin would spend 24 hours sort of swimming on a grid and taking samples at pre-designated places, going up towards closer to the surface and then diving deep down again. And again, collecting a similar profile of information that the SEALs were giving us and also that we would get from the CTD. But unlike the SEALs and the CTD, you can send Hugin exactly where you want it to go. Sometimes Hugin was late to the party. It would surface and we would be looking for its little beacon signal telling us that it was at the surface, and we wouldn't hear from it when we were supposed to. And it was always very nerve-wracking. What you can see in this photo here is a section of the fuselage that was damaged during one of the deployments. We think that Hugin might have come up under a chunk of ice, even though it has ice detection software on it that allows it to not do that. But it's really hard to predict what the environment is going to be like in Antarctica, so accidents do happen. So the fuselage was damaged and a panel was missing when we got it back, and one of the technicians fashioned a new panel out of some scrap metal that was on board, and I wrote this message in mud on the side before its big mission in Amundsen Sea, and remarkably it survived. I mean, remarkably my scribble in mud survived. It's not remarkable that Hugin survived. We expected that. So this is Anna Wolin, who was the lead scientist on the project that was using the Hugin. And basically every time the Hugin was off the ship, this is where you would find Anna, just kind of up on the bridge of the ship, looking out at the sea and waiting to hear back from the technicians in the computer lab that the Hugin was communicating effectively and surfacing on time, et cetera, et cetera. And this, you can see everybody is sort of waiting with bated breath in the computer lab, trying to find out when Hugin came back and what it has to tell us. And I just want to take a moment and acknowledge the brilliance of Anna Wolin. It's really inspiring to get to sail with people like Anna and Lars and all of the other people that were on the ship for really every cruise I've ever done. Anna in particular is very bold and driven in her pursuit of knowledge, and she is the one who orchestrated the process of sending Hugin under Thwaites Glacier, which will give us the first ever glimpse of what's going on down there. It was, it's dicey to put your neck out there and do a project like this when you're working with a $4 million piece of equipment that has never been used in this capacity before. But in the end, her ambition proved worthwhile, and we acquired some incalculably valuable data. So this is a photograph I took of her when we made a brief stop at Rothra Station, which is one of the British stations. So when we got down to Thwaites, we spent some time using the ship's sonar to map the bottom, and then we also did a few deployments with the Hugin. And so these yellow lines sort of trace our track all along the edge of Thwaites Glacier. And in the time that we were down there doing this mapping work, you can see here this little nubbin sticking out is part of Thwaites Glacier. So we came down and sort of zoomed around in here and did quite a bit of mapping work. The little red dot is indicating the position of the vessel. And this sort of fuzzy semicircle here is what's known as the Western Melange. And this is part of that like packed in ice that's maybe frozen and let go a few times over, you know, who knows how long. So we came down here and we were doing our mapping work, and then we went back up to this area over by Pine Island Glacier to recover some moorings. And during that time, this is a period of, I think, 4 days, there was a major event. And so this is satellite imagery. So the image on the left is, I think, on the 2nd, and the image on the right is on the 6th of March in 2019. And you can see that what was this densely packed glacial edge is now a massive shattered ice field. And all of that ice just let go and dumped out into this bay in front of Thwaites Glacier. And to give you an idea of the just how big this event was, this area represented in this like vaguely rectangular spot is about 25 square miles. So for the local folks, if you can picture the entirety of Rockland Harbor from South End all the way up to the beach by the breakwater, completely covered in ice that is 80 feet thick. That's about what we're talking about when we look at this event that occurred. And this is what that area looked like when you look out. So it was interesting because these types of events are not perceptible to the human eye. When we went down and did our initial mapping, we came back a few days later and it's like, you know, this looks different than it did before, but it's hard to kind of put your finger on it. And the mates who do the navigation were saying like, yeah, there's ice that wasn't here before. But then when we looked at that satellite image and saw just how significant this event was, it was pretty jaw-dropping for everybody that was on board. So these are some drone photos that were taken of that ice field. And this is what 80-foot icebergs look like from a zodiac. And just remember, when you look at this, that's 10% of the iceberg. And so there's about 800 feet of ice below this. That's another picture of the Palmer sitting out in the middle of that ice field. And So we had done our core sampling, we'd gotten some mud samples, we had gotten some water samples, we'd sent Hugin on a few successful missions and gotten some incredibly valuable data from that. And we had a couple days left over in the time that was allotted for us to be down there, and we decided to afford the opportunity to do some more seal tagging and
Holy crap.
Oh, that's awesome. Yeah, they get up. The other one got up on it.
So those are some emperor penguins. Not a lot is happening in Antarctica on any given day, and so anytime there's something strange happening on an ice floe, you can pretty much expect a penguin to pop up and check you out. And there they are surveying the scene as Lars does some more seal tagging. And not long after that, we concluded our activities and began our very long trip back north. And this little guy said goodbye. So we saw some incredible things on that trip, but it's important to remember that this was mostly reconnaissance and information gathering. So it will take a few more years to compile enough data and then process that data to fully understand what we're seeing. So for those who are interested in learning more about the Thwaites Glacier study or any of the other aspects of the US Antarctic Program, I have provided an online media supplement that Carney will be posting to the FOMSI Facebook page, which is how you all got here tonight, presumably. I've included some artists that have done artistic interpretations of work that's going on in Antarctica. There were the reports that were done by Public Radio International about the Thwaites Glacier cruise is in there. There's a couple of articles from National Geographic. I am just giving like the scantest overview of all of these things that are going on, and it's incredibly interesting, and there's just so much to learn. So I really hope that you all go check out those resources. And that is the end. So thank you all for coming.